In this video, I want to show you what some of the inverse trig functions would look like if we were to sketch them on a graph. And the first trig function we're going to look at uh, is inverse sine. So let's just go ahead in our graphing screen and put inverse sine of x, and we'll go ahead and zoom with the trig zoom. And as you can see, it just fills up this part of the graph. Its domain there is only going from negative pi over 2 to positive pi over 2. So that's what your sine or arc sine of x is going to look like. To get arc cosine, we'll zoom 7. And now notice it has a domain of only negative 1 to positive 1 crossing through that y-axis in the middle. And finally, let's look at what arc tangent would look like. And as you can see, it kind of tails off and hits an asymptote on the left and on the right equally. So as you can imagine, our graph that we're going to sketch should look something like this. Since it's being divided by 2, we would expect it to be expanded horizontally since that's inside the function. Let's go ahead and figure that out. So my suggestion for this would be to get this in terms of something we're more familiar with, which in this case is tangent. So if we have y equals arc tangent of x over 2, we can take the tangent of each side. So tangent of the left would be tangent of y. Tangent of the right, if I'm taking the tangent of an arc tangent, I'm simply going to end up with x over 2. So then I can multiply both sides by 2, and I get x essentially is equal to 2 times the tangent of y. So when I put in y values uh, that I know the tangent of, then I can figure out what x would be. So let's use some common ones. We know that, let's see, if I put 0 in for y, then I would get 0 out for x because tangent of y is 0. Let's try something like negative pi over 2. If I put negative pi over 2 in for y, uh, tangent of pi over 2, negative pi over 2 is going to be negative 1 divided by 0. So I'm actually going to get undefined here. And that would also happen over here if I did positive pi over 2, because I'd have 1 divided by 0, which is also undefined. So let's try some other values. Let's try, um, I don't know, pi over 4 is kind of in the middle there. So we'll say negative pi over 4. Um, the sine and cosine are the same for pi over 4, so only one's negative and one's positive. So we're going to get negative 1 there. And the same would happen if I tried positive pi over 4, except now they're the same and the same sign, same value and same sign, so we're going to get 1. Uh, the ones in between here, we have pi over 6 or negative pi over 6. One's just going to be the opposite of the other. We're going to have 1/2 divided by radical 3/2. So essentially 1 over radical 3. When we rationalize that, it's going to come out to be radical 3 over 3, which we've seen things like this earlier. It's radical 3 over 3. And then when we look at pi over 3, positive and negative, it's just the opposite. We've got radical 3 over 2 divided by 1/2. So we'd have radical 3 over 1, or just radical 3. So let's kind of verify that with the calculator. There's my original tangent inverse function. Let's take the inverse tangent of x over 2 and graph it. So here's my original, and here's my uh, my final one. And I think let's see here. Let me just look at that one more time. See which one was which. Okay, yeah. So as I said, it does appear to be expanded a little bit horizontally. I couldn't quite tell the difference between the two graphs, but as our table shows, it seems to be doing what we expected. It crosses at the origin. Um, at pi over 2, it becomes undefined, so there's nothing uh, nothing we can do that has an asymptote. And it reaches 1 at about pi over 4. Um, but you could have figured out what these values are and graphed it on your own in much the same way that your calculator would do. So go ahead and see if you can determine what the graph of inverse sine of 2x would look like.